quality control captivates your party patrol. Your mind, body, and soul flow. The bell tolls like the rhythm explode. Big, bad, and bold people.
Okay, number 2 asks us to write an equation for a rational function with the given characteristics. So we have vertical asymptotes at 5 and -5 for x, and then x-intercepts here. So these are the horizontal intercepts, right? So I'll just label them horizontal intercepts, and a y-intercept here, okay? So what are we supposed to do with all of this information? So remember, the general form looks like something like this, right? Where x minus x1, x minus x2, so on and so forth, over, and then to some power, right? Some power, blah, blah, blah. And then x minus v1 to some power, and then x minus v2 to some power, all of that stuff. On the top, we get our horizontal intercepts. Those are our x1, x2, and so on. And on the bottom, that gives us vertical asymptotes, the v1 through v2, blah, blah, blah. All of that stuff, okay? So what we can do with our information is say, okay, so this x equals 5 and x equals -5, these are like our v's, the ones on the bottom, right? So what we can do is start to construct the equation for our rational function. So this is going to be like x minus, let's do the first one. So 5, we're going to put in for one of them, and we're going to put in minus a -5 for the other one, okay? That'll just amount to x plus 5. And then on the top, we just need to, they already gave us our horizontal intercepts, right? So we have x equals 2 and x equals -1. These are kind of like the top values, okay? So we have x minus 2 and x minus a -1 on the top there, okay? So now if we just simplify, we just get a times, a is some unknown coefficient, right? Some constant. And so x minus 2 times x plus 1 on the top over and x minus 5 and x plus 5. Okay, so now you might be thinking, okay, so again, how do I find this random a here? And the trick is just to look at the question and see what other information they give us. And they gave us a y-intercept of x of 0, 4, right? So this is like our x and y, right? So we can just plug those in, plug that point in, and that's definitely not a horizontal intercept, right? Because the y value is not 0. So we can plug it in and just figure out our a. So let's do that on the next slide. So we have f of x is equal to a times x minus a 2, and then x plus 1 over x minus 5 and x plus 5. And we were given the point 0, 4, so let's just plug those in. Yeah, that makes sense. So 4 is equal to a times, and then this will be -2 times a 1 over -5 times a 5. So the negatives cancel out, right? We can cancel out 2 on both sides. So we get that a is equal to 2 times 25, so a is equal to positive 50. And we can just put that all together, so we get f of x is equal to 50 times x minus 2 times x plus 1 over an x minus 5 and x plus 5. Okay, and that is the equation or the formula for our rational function. Okay, last but not least, number 3, we're going to write an equation for the function graph. So this is very similar to question number 2, except for here we're going to be reading from a graph instead, and then deriving a formula or an equation for our function. Okay, so the first thing is the red lines indicate vertical asymptotes. So we have one at x equals -3 and one at x equals +3. But you can see how at each of these there's different behavior going on, right? So at x equals -3, our graph is going up on one side but down on the other. So here's opposite behavior, or unlike. So that means we have to have an odd power for this one on the bottom, okay, in our denominator. How about this one though? When x equals +3 at that vertical asymptote, we have both sides. It's approaching infinity. Our function values are. So here is like behavior, or same. So like or same behavior, right? Okay, so that means that implies we have an even power on that one on the bottom, on that factor. Okay, let's see what else we have, what else we can read from the graph. We have, let's see, a horizontal intercept of 2, so horizontal intercept of 2, 0. Okay, so that'll be on the top somewhere floating around. Let's see, do we have anything else? Yeah, so we have a vertical intercept of 0, -2. Okay, so let's see what we can do with that information so far. So we're going to write, okay, so f of x is equal to some constant, which we don't know yet, right? And then times x minus any horizontal intercepts we have. So that would be 2, because we only have one horizontal intercept in this case, right? Because even these ones, I think they're just going to approach 0 in the long run. So we have x minus 2, okay? And we can tell that this is linear, like it has a power of 1, because if we draw like a little box around it, it looks pretty linear, right? There's no like parabolic or S graph going on there, okay? So we have something like that, and then on the bottom, we're just going to write x minus any, not x minus, but x minus any vertical asymptotes that we found from our graph. So the first one's going to be x minus a minus 3, right? So that would be like a plus 3, and we knew it had to be odd, right? Because we have unlike behavior. So we're just going to write a 1 there for that power. So we'll just put a 1 on this one because that's an odd power, right? And then for the other vertical asymptote, we have x minus, and then that would be a positive 3, and we see that we should have an even power here. Because we had like behavior, right? Because they're both approaching positive infinity, so we have something like that, okay? And now in order to determine our a, we could just use any other point other than a horizontal intercept, so we can use our vertical intercept in this case. So that would give us negative 2 is equal to a times, let's see what we have here. So we have a negative 2 on top, and then this is over a 3 times negative 3 squared, so times a 9. And then, so those negative 2's actually cancel out, which is nice. And we get a is equal to a positive 27. Okay, so now we just plug that in, and we get the equation for our function. So this is going to be a positive 27 times x minus 2 over an x plus 3 times x minus 3, and then squared, just on that one. Okay? And that gives us the equation for the function in the graph. Alrighty, that wraps up our practice problems video for the section on rational functions. I hope that helps, and good luck on your homework.
We're going to take a trip back in time. Are you ready to get into your time machine? Okay, fasten your seatbelts. Are you ready?